bucka. Haha. You know the deal.
The next thing we're going to talk about in our patterning unit is something called geometric patterns. And the first question you're probably going to ask yourself is, what is a geometric pattern? And a geometric pattern involves a repeating set of shapes. So we're going to take a look at a couple of examples of those. So in our first example here, we can see that we've got a repeating set of shapes in that we have our black square, red square, heart, and then cross, and that set is repeated over and over and over again. And presumably this pattern could go on forever. So if we were going to continue this pattern, we would look at the first value in the set, because we're starting a new set here, and we would draw a black square there. Here's another example where again we have a repeating set of shapes. In this set we've got a blue triangle, red circle, and then a star, and that pattern repeats itself over and over again. And again we assume this could go on forever, so if we were going to continue the pattern, it would be that set just repeated. So a blue triangle, red circle, and then a star. Well, up until grade 6, you've pretty much just been expected to continue these patterns, to repeat what you've already seen. What we're going to take a look at next is something that we've talked about in previous videos on number patterns. And we can see here that the first shape is a blue triangle, the second shape is a red circle, and the third shape is a star. And that pattern repeats. So continuing the pattern is fairly straightforward. But what we're going to talk about in this video is finding what's called the nth shape in the pattern. And what I mean by that is, we continue on this pattern here. We've got the first, second, third, our fourth, fifth, sixth shape, and so on. But suppose we wanted to know the 72nd shape in this number pattern. Well, we're going to talk about how to get that, what that shape would be in this video. And this has practical applications for things like cutting material. So where you're making a piece of clothing that has a repeating pattern on it, and you want the patterns to match up. You might want to know what your 72nd or your 85th or your 137th shape would be in the pattern of shapes. So when you're trying to find the nth shape in a geometric pattern, and I just want to talk about that phrase nth for a second. So as we've seen in previous videos, when we have pieces of information that can change, we can assign a letter, call a variable to it. So here I'm assigning n to the position that we're at in the geometric pattern. So the first, second, third, or nth position is what we're talking about here. So we can figure out wherever we are in the geometric pattern, what shape will be there. And there's really only one question you have to ask yourself when you're trying to do that, and that is, how many shapes are in a set? So in the first example we're going to look at here, we've got blue circle and then a red square, and that's the pattern. That's the geometric pattern that's repeating over and over again here. So blue circle, red square, continuously. And when we ask ourselves this question, how many are in a set, here we can see that in a set that repeats over and over again, we've got 2 shapes in this set. And it's really the set that's repeating over and over again. So you can see the set of blue circle, red square is the pattern here that's repeating over and over. And again, there we've got 2 shapes in each set. Well, in this next example, again we have a geometric pattern, and the pattern is, we've got blue triangle, red circle, star, and then blue square. and that set is repeated over and over again. So here you can see we have 4 shapes in each set. So if we go back up to that first example for a second, if we're looking at the actual position where we are in the pattern, we can see that our first shape is a circle, and our second shape is a square. Well, continuing on with the pattern, our third shape is a circle, and our fourth shape is a square, and so on. And you know, as we've talked about, these patterns presumably could continue on forever. So there we've got our fifth and sixth, and our seventh and eighth, and that's all that we've got there. But it could keep going. So if we were to look at this geometric pattern here, and we were wondering, well, what's the 88th shape in this pattern if we were to continue it? Well, we could keep drawing shapes until we got to the 88th shape, but that could take a while. So we might want to come up with another strategy to try to figure out what the 88th shape might be. And I encourage you to just pause the video for a second and see if you can figure out what you think the 88th shape might be and why. And hopefully you were able to come up with recognizing that in this geometric pattern here, every second shape is a red square. So in other words, if we're at an even numbered position in this number pattern, it's going to be a red square, because our red squares are in the even number positions, the 2nd, 4th, 6th, 8th. If we kept going, it would be 10th, 12th, 14th, and so on. Well, we recognize that the 88th position is an even number, so it must be a red square. So when we're talking about even numbers, what we really mean is that they're all evenly divisible by 2. So this again, 88th shape had to be a red square, because 88 is divisible by 2, and we know that every second shape is a red square. Well, if we look at the next example, it gets a little bit more complicated, because we're not just dealing with even and odd numbers here, because there's more than just 2 in each set. There's 4 shapes in each set. So what we're going to take a look at here is counting in 4s in terms of the position where we are in the geometric pattern. So here, our 4th shape is that blue square turned on its side like that, or on one point. And if we continue counting in 4s, our 8th shape is the same shape. So because we have 4 shapes in a set, every 4th shape here is going to be that blue square turned on its vertex. So in this geometric pattern, if we're trying to find out what the 88th shape would be, there's a little bit more to it than just recognizing whether it's even or odd, because we have more than just 2 shapes here again. So what we're going to want to know here is, well, is 88 divisible by 4 evenly? Because it looks like if we're counting in 4s, so here we have the 4, the 8, the 12, the 16. If 88 is a multiple of 4, or in other words, if 4 goes evenly into 88, we know that that shape has to be that blue square turned on its vertex. So let's check to see if it's divisible by 4 evenly. Now, there are a couple of different ways to check to see if a number is divisible by 4, but one of them is to just do the division. And here we'll do long division to try to figure out if this goes in evenly. In other words, if we can divide it with no remainders or without going into the decimals. So I'm not going to explain step by step what long division is here, but hopefully you recognize the steps that I'm going through to divide 88 divided by 4. And when we get down to the ones place, the last place that we have here, we can see that we do have a 0 remainder, which means that 4 does go evenly into 88 22 times. So because it goes in evenly, we know we're going to have that blue square turned on its vertex in the 88th position. And again, we know that because every fourth shape here is a blue square turned on its vertex, and because 88 is a multiple of 4, in other words, if I kept counting in 4s, eventually I would get to 88. That 88th shape has to be the blue square turned on its vertex. And now hopefully you're asking yourself, well, what if you did have a remainder? What if it didn't go in evenly? Then how do you figure it out? And that's a fair question, and we're going to explore that next. So if we look back in our pattern that we have here, where we have the 4 shapes in a set, let's just take an example of one of the positions. So let's say we wanted to know what was in the 15th position, but we didn't have to draw this pattern this many times. We just, we know that the star is there because we can see that in the 15th position we have a star. But I want to use the method that we talked about over here, where first we'll check to see, well, is 15, is it a multiple of 4? In other words, does 4 go evenly into 15? So let's pretend for a second we don't know that the 15th shape in this pattern would be a star. So when we go ahead and do the long division again, if we stop at the ones place, if we don't continue into the values that are after the decimal, which we're going to talk about later on, if we stop at the ones, we can see that 15 divided by 4, well, it goes in evenly 3 times, but then there is a remainder of 3. Now, what this means in terms of this example is, well, remember, we're dividing by 4 to see how many sets we have in the 15 here. And when we're trying to get to the 15th term, we have 3 full sets we go through. So we have the first set that we go through, the second set, and then the third full set. So that's where this 3 comes from. We're going to go through 3 full sets, but we have a remainder of 3, which means to get to the 15th position, we have to go 3 more of the shapes. So when you get this remainder, when you're trying to answer a question like this, it's how many positions in from the start of the pattern that you are. So our third shape here is a star, so we know our 15th shape has to be a star because we got a remainder of 3. 3 full sets. Here's our first whole set, our second whole set, and our third whole set, and then 3 more shapes into the set to get to the 15th. So here's another example where we have a repeating geometric pattern, and in this case we've got a blue circle, a red square, and a blue star repeating over and over again. So again, when you ask yourself here, how many shapes are there in a set of shapes in this pattern? So again here, if we're talking about the position of where we are in this pattern, we've got the first, second, third, and then from there I just put every counting in 3s. We do have the 4th, 5th, and then the 6th, the 7th, 8th, and the 9th shapes there, and presumably this pattern can continue on forever. So let's say here I wanted the... So suppose we continued this pattern and I wanted to know what the 122nd shape would be in this geometric pattern. Well, again, I don't want to keep drawing these shapes over and over again until I get to the 122nd position, because that'll take forever. So instead, we'll see that we have 3 shapes in a set. So first thing I'm going to calculate is how many full sets do we have in 122 positions. So we divide 122 divided by 3. And when we divide 122 divided by 3, we get 40, which means we have 40 full sets, so 40 of these sets of shapes to get to the 122nd shape. But then we have 2 remainder, which means we have to go 2 more shapes to get to the 122nd shape. So that means the 122nd shape must be a red square. So again, we're trying to figure out what shape would be in the 1584th position. I don't want to draw these shapes that many times, so we'll start by seeing how many full sets there are to get to the 1584th position by dividing 1584 by 3, because there are 3 shapes in each set. And when we do that, we find that 3 goes into 1584 528 times with 0 remainder. So in other words, 3 goes evenly into 1584, which means we have 528 full sets to get to the 1584th position. So since we're at a full set here, we must be at the end of the set, which would be a blue star. So to finish off our lesson on geometric patterns, I'm going to ask you to answer a couple of questions here. So for that first pattern there, I want to know what the 175th shape would be. For the second geometric pattern there, what color would the 53rd car be? And for the last one, what would the 2485th shape be? So hopefully you're able to figure out how many full sets are in each one of those questions, and if there is any remainder, what that remainder means. With the last one, just take a careful look at the number before you start to go through the process that I suggested in this video, and see if you can figure out, without doing the long division, what you think the 2485th shape could be. If you're able to do that, congratulations, you now have a firm understanding of geometric patterns and finding the nth shape in a geometric pattern.